Welcome to the video for C1.2.1 where we're going to look at atomic structure. So just to start off with, you need to find your periodic table and find these chemical symbols and write down the names of the elements in your book. Okay, so pause the video. Okay, so we should have found that Mg is magnesium, the Al is aluminium, Li is lithium, Cl is chlorine, and Pt is platinum. Now, we need to be careful when we're writing chemical symbols. So the first letter has to be capital, and then the second one has to be lowercase. And this is important because otherwise it can be a different chemical. So for example, if I wrote these two, they mean different things. So if I write capital C and lowercase o, that would be cobalt. If I wrote capital C and capital O, that would be a compound called carbon monoxide. And that would mean that I've got one carbon atom there and that is an oxygen atom. So we have to make sure that we write the first letter as capital and the second as lowercase. Okay, so our lesson objectives for today: you need to be able to recall the relative charge and masses of protons, neutrons and electrons, and then use the periodic table to work out the number of protons, neutrons and electrons in an atom. So first of all, what does an atom look like? So you need to copy this diagram down into your book. So the nucleus is this bit in the middle here. So this is the nucleus, and the nucleus is a tiny bit in the center of an atom. So most of the atom is empty space. This is not to scale. Okay, so you've got these with a positive charge in are called protons, with no charge in are called neutrons, and then in shells around the outside. So these circles are called shells, and that's where the electrons sit. So can you copy that diagram into the book, please? If you follow that link, so if you go to EdTech, a video called Just How Small is an Atom. Right, so now we need to copy this table into our book. So as well as being able to draw our diagram to show where the subatomic particles are found, we need to be able to remember the relative charges and masses. So remember, we had the nucleus in the middle, so we had protons in the middle and neutrons in the middle, and then we had our electrons here. So the electrons were in shells. That's my neutron. That's my proton. And these are all subatomic particles, which so sub means kind of smaller or make up the atom. So atoms consist of protons, neutrons and electrons in different combinations. So protons, so the way to remember this is that P means positive, and therefore it's got a +1. So it's very important that we have this plus there. Neutrons, so you might have heard the word neutral to mean, like if two people are having an argument and somebody's neutral, that means they're not taking either side. So neutral means no charge in this case, so there's no charge on it. And then the electron is -1. So the protons and the electrons are oppositely charged. And then in terms of mass, a proton has a relative mass of 1 and a neutron has a relative mass of 1. And then an electron is 1/2000. So you can write 0 in an exam. You can also put it as 0.0, so 0.5 would be 1/2, so 1/20, 1/200. So you can also write it as this. But the problem with that is it's difficult to remember how many decimal places to put in. So you could also write that, or you could write 0. So if you look in the periodic table, there are two numbers. So there's the mass number, which is the biggest, that's the biggest of the two numbers. Unless you're looking at hydrogen, and hydrogen, both numbers are the same, but that's the exception. And the atomic number is the smallest of the two numbers. So I think in your periodic table that you use for your exam, it's actually this way around. So it's important not to say the bottom or the top. It's the biggest and the smallest. And this atomic number, the smallest number, is sometimes called the proton number because it tells you how many protons there are. And that's in an atom which is neutral, that's the same as the number of electrons. So if I see this in my periodic table, I can immediately see that I've got an atomic number of 3, so I've got 3 electrons and 3 protons. And then the number of neutrons is the difference between these. So it's 7 minus 3 equals 4. Therefore, I've got 7. Okay. And the reason we have to have the same number of protons as neutrons is, remember that protons were +1 and the electrons were -1, and atoms don't have a charge, so you need the same number of electrons as protons. So if you can copy this box down here, so you need to be able to do this today. So number of protons is equal to the number of electrons, which is equal to the atomic number, and the number of neutrons is the mass number minus the atomic number. So if you can just put that down. Right. So there's a worksheet on the learning platform and the answers, so you can check the answers, but I'll talk you through the first examples. So basically, the first one gives you carbon as being this. So it's got two numbers, so that's our mass number, because it's the biggest number. And this is our atomic number, because it's the smallest number. So the number of protons is equal to the atomic number, which is the smallest. So for this, it's going to be 6. And then the number of electrons is going to be the same. So it's also going to be 6. And then the number of neutrons is going to be the difference between the numbers, so it's 12 minus 6, which is also 6. So carbon has 6 protons, 6 electrons, and 6 neutrons. Now, if you look in the periodic table, so chlorine's unusual, and if you look in the periodic table, it will have 35.5, but we're going to use one of the isotopes of chlorine. Now, you don't know what that means, but we're going to learn about that next lesson, so don't worry about it for now. So if we take 37 chlorine, then the number of, so let's do this as a table, because then I don't have to keep writing it out. So the number of protons is the smallest number there, so it's 17. The number of electrons is the same, so it's also 17. And then the number of neutrons is 37 minus 17. It's the difference between the two numbers, so that's going to be 20. And then the last example, if you find fluorine in the periodic table, it's 19 and 9. So the number of protons is going to be equal to the smallest number there, which is 9. Number of electrons will be the same, and then the number of neutrons will be 19 minus 9, which equals 10. I'll go to the rest of the questions now. So now you've done that and you've checked your answers, if there are any you're unhappy about, email me. So for this one, you just got to work out which element it is referring to, and then write both the name and the chemical symbol for each. So I'm in group 2 and I've got 12 protons. So pause the video and work out what element that is. I've got 2 electrons and I'm in period 1. I belong to group 3 in period 2. And I'm in group 1 with 12 neutrons. And lastly, I've got 110 neutrons. Okay, so pause the video, answer those 5, and then unpause the video and check your answers. So we should have found magnesium for the first one, helium for the second, aluminium for number 3, sodium for number 4, and tungsten for number 5. Okay, so last thing for you to do is just have a look at these 2 jokes and see if you can explain the science behind them now that you've done this video. Okay, thank you for listening. See you next time.